right, good morning, everyone. For those of you that are new here, my name is Shelby Pritchard. I am currently the IPM specialist here at SDSU, as well as the moderator for the webinar series. I appreciate all of you taking out your time this morning to be here with us today. As always, I just have a couple of quick reminders. At the end of our talk today, there will be a short poll with a couple questions. We ask that you please fill that out. It will remain anonymous and it just helps us for planning down the road. And as always, I will pull up a CCA credit at the end of the presentation today. And make sure if you have any questions, type them in down in the Q&A feature. We love to answer anything. So we have one speaker today. It's Anthony Bly. Anthony obtained both his bachelor's and master's in agronomy and soils at SDSU. After school, he went on to be a research associate at SDSU Soil Fertility and Testing for about 19 years. Then from 2011 to 13, he was the lab manager and agronomist for Ag Lab Express in Sioux Falls. And from 2013 until now, he has been the extension soil field specialist in Sioux Falls, where he specializes in soil fertility and soil health. And today, Anthony's title is Really, You Can't Do That Here.
Thanks, Shelby. I'll share my screen. Can everybody see that okay?
Looks good to me.
Okay. Yeah, I've been told this is really an enticing or maybe edgy title. You know, we struggle lots of times with getting a title that will attract people's attention. And, you know, the title really comes from the fact that I work with a lot of producers that are doing soil health practices and maybe no-till as kind of the base there, but it's really about soil health practices and others that you know, when they told their neighbors or their family what they wanted to do or what they're going to do or what they're doing, this is kind of a common statement. You know, you can't do that here. And so I just added the really as a question, but it's really both a question and a statement. So that's really what's behind the title. And so I'm going to discuss a little bit about problems that we have. We don't want to hone in on the negative too much, but it's real, it's there, and it needs to be talked about as far as soil health. Then I'm going to talk a little bit about my farm. I've really held off doing that in my professional life. I did give this presentation at the South Dakota Soil Health Coalition's conference in January, and they asked me to talk about my farm. But, you know, I understand science, and I'm a scientist, and so I have to stick to the science. So sharing the anecdotal nature of my farm, I think I've tried to bring in some science and some soil information there so you can kind of learn from that as well. But let's start out and talk about that picture. What's a picture of a flower doing on my title slide? Well, I took that picture, and in a live audience, I would ask to see how many people recognize that flower. I'm not a florist. I don't have any interest in gardening flowers per se, but so I'm just going to give you a second and ask you if you can identify that. So that's really the past flower. That's our state flower. And in a group of 300 people, there was less than 10 that could recognize that flower. And so I'm just going to throw this out here. What have we done? What have we done to our environment, the ecology of our environment, for these species to really disappear? They're really disappearing. So let's think about that in the background as we go through this just a little bit. It's not advancing. What's going on here? There we go. But anyway, let's start out with a little bit of the negative here. I took this picture in 1993. That's 2 miles from my family's farm. I didn't put it up here to talk about my neighbor. Nobody knows who farmed this farm then, or who even owns this land now. That's not my point. But in 1993, it was a higher rainfall year, and we can see a field here that obviously has poor soil health. And in 1993, soil health wasn't even a thing, wasn't talked about at all. I was in school prior to that at SDSU, and had great soil professors there that taught us about soil physics and conservation. And so I learned from them, as well as my father, how to identify these issues. And so we just see a field here that just can't take in any more water. And granted, there was a high rainfall pattern that year, but this field violates all the soil health principles. So let's take a look at that field again in 2019. And so history repeats itself. And this is the same farm. I'm not exactly in the same position. That last picture was probably more to the left of this photo, but I wanted to capture the essence of all the runoff that was taking place from this field. So where have we come from that photo in 1993? Obviously, we have a lot more technology, a lot more knowledge now. We know about practices that can essentially stop this soil degradation process. So about 20 seconds later, I took this picture. This is right across the road, and this is the culvert outlet from the opposite side of the road, and you can see the torrent of water running down through that field. And if you look really hard, if you center on the white water in the middle and go to the left and the right, it kind of gives you the impression that the slope goes down to the right and goes down to the left. And it does, because there's a big plume of what most people would call silt there. We would call alluvium. It's being deposited by water, but huge amount of deposition of erosion material from the other side of the road. And this last year, I can tell you that the owner of this land had a heavy equipment come in and clean that out and reshape that waterway. So I don't know if they recognize the problem, but that's what's going on there. So if we go a little bit farther down that stream, about 5 minutes later, here's this stream that's growing because a lot of tributaries are contributing to it, and it's carrying a huge sediment load as well as a huge organic matter load. The stalks are detached from the soil and they're floating down here, and they make huge dams. And it was kind of surreal just to stand there and watch these big chunks of residue come and being trapped there in that spot. And then, of course, across the road, it's much more of a torrent. Again, this is the down side of that where the culvert is coming out, and we see this torrent of water essentially heading its way to the Delta and the Gulf of Mexico. So these are examples of poor soil health, water erosion in particular, that happen. And here's a discussion about wind erosion. And so up in the upper right hand corner, you can see a field that's probably following most of the soil health principles. It's a low residue crop. I'm not trying to pick on soybeans at all, but it's a low residue crop. But you can see how clean the snow is. And all of these pictures were taken the same day. If you go to the lower left, that's again a low residue crop, that the soybeans, and it's a conventionally tilled field, but it hadn't been tilled in the fall, and yet it's still showing evidences of blowing soil. If you go above the lower right up to our lower left up to the upper left, a low residue field, conventional till, but it had fall anhydrous ammonia applied to it. And you can see that There isn't much of a difference between those two pictures on the left-hand side there, but I think you could maybe agree that the upper left is a slightly worse than the lower left, because the lower left has some snow on it yet. There's something holding there, with the upper left is kind of barren. And all of these pictures are within a mile and a half of each other. And then the lower right is the extreme worst case scenario of the low residue, soybeans, I should say, a conventionally tilled field where they baled the residues and then they applied fall anhydrous ammonia. And those are drifts of dirt. And you won't hear a soil scientist say dirt very often, but those are drifts of dirt out in that field. So two really kind of negative pictures of water erosion and wind erosion, soil degradation. This is what the soil health education is all about, is to help farmers stop these processes and to preserve their soil, to sustain their soil, and even regenerate, build their soils. And so that's a big movement that's going on right now, if you're not aware of that. I don't know how you cannot be, but just in case you're not, that's what's going on. So I'd like to review the principles, and you know, these are my interpretations of the principles. Basically, I'm not deviating from what they really are, but it's kind of how I think about them in my mind. And so first one is armor, or soil covering. It protects the soil structure. And open pores. I think the open pores to the soil surface have been overlooked, because we need those to improve water infiltration and to exchange air. And if we plug those pores, that leads to problems. The second one is no tillage, or very, very reduced tillage. It just enables soil structure to develop and for those pores to remain open. And also a caveat there is tillage releases carbon. And I know we're all inundated with the climate and then the carbon and all those things, but carbon is a good thing for soil. Carbon is highly correlated to soil productivity. And we know that, we've known that for forever. So ancient civilizations lost their soil resource because the carbon disappeared because of their practices. Diversity, providing soil biology is something more to feed on than just the monocrops. If we have a monocrop, we kind of just train, or we cause that soil biology to be more just, you know, mononistic, if that's the right way to say that. But diversity provides the ability for different classes and groups of microbes to thrive. And it's like going to a buffet. If all you had was mashed potatoes to eat, how boring would that be? But a buffet provides all kinds of different foods that each one of us like or dislike, and so everyone seems to be quite happy. And that's the idea of diversity. Living root as much as possible. Really, that is the place at that root surface of the great exchange. And I've said that many times, and I'm going to keep saying that, because that's the place where carbon is traded for nutrients. And so sunlight meets soil right there at that interface. And I know some have referred to that as liquid carbon and things like that, big catchphrases, but it's the place where the microbes meet the plant. And so that living root as much as possible, that's the idea of cover crops and you know, in the spring and late in the fall. Our prairies, you know, provided that. And so it fed the micro populations in the soil and kept that nutrient cycling going. And then lastly, livestock integration. If you have livestock, it's a great tool to provide nutrient cycling. It's a great tool to convert that above ground biomass into more stable forms of carbon and nutrients for the soil to help feed plants down the road. So my thoughts about the soil health principles, usually when I'm called to a field and there's an issue with something, it's usually because one of these is a problem. And so you can really figure that out by thinking about these principles. Okay, a little bit about our farm. My great-grandfather came here in 1896. He built this farm up, and this is a picture in the 40s. You can see a corner of this photo is missing. Quite a feat to have an aerial photograph from the 1940s of our farm. It doesn't look like this today, and that's not my point, but my point is to establish a history, to think about history and where we're at in that history and technology and why producers did things back then the way they did them and why we should be doing them differently today. Okay, so there it is. I can't point at the picture, but kind of in the middle bottom, there's kind of a rectangle there that's dark. That's my great-grandmother's garden. And think of the sustainability that those folks had to endure and were forced really to do. They really knew how to survive on their own. So there's a picture in the 1920s. There's that big house. That big house is still there. My mother lives in that house. That's my grandfather in the middle, the taller fellow there, dealing with the horses. And so just think of this history as we go, and they're forced into doing tillage, and because there was not technology that they could no-till or apply things in different ways. And then moving on to 47, that's a picture of my mother's farm where she's from. My grandpa's putting the ear corn in the corn cribs. Just thought that was a neat kind of progression there. They went from mechanical or manual harvesting of corn to mechanical harvesting of corn by that time. Just some things to review here in the, prior to 25, they had a diverse rotation of oats, corn, alfalfa, small dairy, less than 6 cows, horses, pulled the equipment, transitioning to tractors. My great-grandpa did grow hemp prior to World War I, maybe into that period for rope. They needed a huge demand for rope. The big barn was built in the 20s. The dairy slowly expanded up to about 40 cows. Soybeans came in the 50s. The dairy went out in 76 because dairies were getting bigger by that time already. Tractors getting bigger, tillage more intense. In the 80s, we went to the corn soybean rotation, tillage even more intense. Although the moldboard plow was disappearing, the chisel plow and type of implements were growing in popularity. Terraces were constructed on our farm. There still was a few oats fields and some alfalfa, but that had vastly disappeared. So here's credibility to the soybeans in the 50s. That's my mom's dad harvesting soybeans on his farm in 1954. We got our first self-propelled combine in the early 80s. You can see it there. Those terraces I mentioned went in the 80s as a tool to fight erosion, but really they're just a Band-Aid. They still allow the erosion to occur, but it tries to keep the siltation on the property, but it doesn't stop the problem. And so, our farm went to no-till practices in the early 90s, and we saw infiltrations improve. We saw no water standing behind terraces, and farm equipment was getting bigger. And so we made the decision to get rid of those terraces in the late 1990s into the early 2000s. And so there's just a picture of us getting rid of those narrow base terraces. And then the picture of the land there in the upper left corner, you can see all of the terraces and how equipment size is changing. And it was just a problem. And really this aerial photography helped us see that issue and to say, wow, what a mess we've made. And anyway, so not all of them have been removed. Only these narrow base ones have been removed, but the large farmable terraces are still there. I don't see them ever going away. So, you know, we've tried some wheat on our farm there in 1999, and our farm has kind of always been known for using older equipment that's well maintained. And so that's not a picture of our farm's combine today, but just a picture of what we think about how we manage our farm. So today, you know, in the 1990s, it was all corn and beans. We started that no-till. Again, Dwayne Beck, I give him the credit for that process. We really look to ourselves as followers of Dwayne Beck, or Beckites, as some people referred to us at that time. Although 93 and 94 are very tough years for no-tilling. And this is why soil health is so important, because it's more than just the tillage. If you just do one of those soil health principles, you're not going to see the fullest benefits. And in that period, we couldn't get the seed furrow closed. We were hauling large amounts of liquid fertilizer with the tractor and the planter and banding all those things. And I was working in Brookings at that time, and working with Dr. Gelderman and Gerwing and Woodard. And we were doing some research with banding and broadcast. And we were finding that the broadcasting was very comparable to the banding. So the tanks came off in 2000, and we started just a broadcast approach. And that's backed up by our research at SDSU, as well as Iowa State University. And I have a whole other presentation about this topic. Other states are finding this as well, especially in the healthy soil health environment. We did move residues out of the row for corn in that time period, and we've gone away from that, and we used a fluff and plant drill to plant our soybeans. So a coulter doing a lot of disturbance followed by a disc opener is what we started our soil health journey with. And now we've changed to a pinch and plant drill, a single disc opener that disturbs less soil. So today is more of a carbon focus on our farm. My dad always knew the importance of organic matter. We didn't think about carbon at that time. We didn't even know, or even could say, what part of organic matter carbon, was a part of there. It wasn't even part of our management, but organic matter was the focus. And again, we made another change on our farm to a new rotation. After hearing Dwayne Beck speak many times, like a hammer hitting me on the head, I just said, well, it's time for our farm to change. And so I made those changes on our farm to a new rotation. It's a corn, soybean, small grain, soybean rotation. So a 5-year plan. We've grown oats, cereal rye, soft white winter wheat, and triticale as that small grain. Our cover crop blend in 21 was all of those things there that you see on the screen. We've tried a number of different things. This is my latest mix that I've made the decision to go to, and there's reasons for that. But yesterday you heard David and Sarah talk about cover crops. I'm not going to get into the reasons why I have chosen that. But we also fly some cereal rye in over mature corn in September, which has worked very well, but have since switched to winter wheat because the rye is a great cover crop. Don't get me wrong. I love it. It's a great soil builder. But you notice we're growing some oats and some soft white winter wheat and triticale there, and we can't have any contamination from cereal rye in those crops. And so we've had to walk out or rogue out volunteer rye in those crops just to get it out of there. So I've gone away from the rye. So not to say it's bad, it's great if it fits your operation, but we've just gone away from it because of those reasons. And we do use precision farming. I know Ollie's going to talk tomorrow about that, and I'm going to leave him do that. I've got a little discussion here about it, but we use soil zone maps, not from the NRCS soil survey. We map our fields based upon soils, the soil survey base, but it's way more high resolution than the standard soil survey. We variable rate our fertilizer, create yield maps, and we have all that other precision stuff as well. The corn is stacked to build up carbon to make it across the 3-year period with the lower carbon crops. By that 3rd year without corn, the residues are almost gone in that first year corn. It's really kind of amazing how the biology has taken over and will just get rid of that residue on its own. Pest cycles are challenged with corn out of 3 years and beans out 2 and grains out 4. That gives us the upper hand with pests, if you will. I know our corn is stacked, but we've really confused some of those corn pests with that stacked rotation. The rotation forces me to rotate my weed control choices, my herbicides. So my active ingredients are rotating. It just forces you to do that. You don't even think about it, but it's happening as in the background, which is a good thing for herbicide resistant weeds. 2nd year corn is tricky. That's no doubt. And I've learned through my observations that hybrids are part of this solving this issue. Some hybrids can deal with corn on corn better than others. That's that allelopathic effect. And so sometimes I get it right, sometimes I get it wrong, and you're going to see an example of how I got it wrong just this year. So I'm willing to admit my mistakes. We learn from our mistakes, and so we have to do that. And but we focus on net profit on our farm and not gross bushels. We do not go after those last bushels. Those last bushels are your most expensive bushels, and so we like to be down on that return curve right before a dollar returns less than $1, if you know what I'm talking about. We don't deviate from our rotation. I keep track of our farm's rotation on a spreadsheet. This one's showing in 2014. It goes out to 2028, I believe. I can't see the right side there, but it's 2028. We follow this strict rotation. We're not looking at the prices and saying, are we going to grow more corn this year or more beans? The diversification is key. It's key and to follow that is really key to the success of the system. Just a picture of us back in the early 90s, what our planter looked like there, carrying all that liquid, stopping every 13 acres to fill up. So we went away from that. You can see we're really moving a lot of residue, and I'll show you a picture of my corn last year, I think it was, where I'm hardly moving any. But here's the planter today. It's nothing fancy on the right there. That's the full package that I have available to me. Generally that coulter on the front is not on unless I'm planting corn on corn. And that chain on the back hasn't been on as much either, since I'm not moving as much residue. If you're moving residue, then that chain is your friend. That twisted link chain will just pull along a little soil to help fill in that seed trench, and help you keep that seed covered. There are no-till seeding principles. I'm not going to talk about that. I don't think I have time, and I'm probably running behind right now, but there are no-till seeding principles that you have to follow to be successful at that direct seeding approach. So here's the winter wheat flowing into corn there on the left. That would be in the 2nd year corn on the upper left picture. That's what it looks like in the spring. And on the lower right, this would be soybeans seeded after a cereal grain with that cover crop. And I always want a winter annual in there, the winter wheat. I love to plant green. I've talked to other producers that love it too. And believe me, and I learned this from Kelly Cooper in North Dakota. He showed pictures of him planting soybeans green while it was raining. And I'm not kidding. This is such a nice environment. The planter stays clean. You've got a nice firm footing there for the tractor. And it's just an awesome awesome system. There's the corn upper left that I mentioned, hardly any residue moved out of the row. I have the residue manager set to deal with any of the mistakes we made when we combined, like leaving patches of too much residue, so that it'll kind of move that out of the way. But by and large, I want to leave a lot of residue there. Just evens out the environment for those corn seedlings to emerge. There's just a picture of us combining corn in the new system. There's our small grains, seeded no-till into soybean residues. We have no problem with that. And there's soybeans no-tilled in those corn stalks with that winter annual that was there. It's totally disappeared. You would be surprised how fast that all disappears. It's kind of an amazing thing. There's the corn on corn. I'm getting a lot better at that, and it was a huge learning curve. And I try to plant between the rows or as close to a row as possible. With the hills that occur there, it's hard for us to do that, but that's the goal. And we just like all of that residue and protection on the soil surface. But you can see bare soil there. In this picture on the left, there's nightcrawler middens there. It's hard for me to point that out, but they're gathering that residue and pulling it down their burrow. And that's an important thing for water infiltration in our system. Some new things we're doing is we desperately need a winter broadleaf. So I've been experimenting with camelina a little bit with David Karkey. I got just a little bit of that to fly on over beans and corn. I'm not recommending you try this as a practice, but just wanted to let you know that when you're in this frame of mind, you're always trying something new and thinking about something new. It's not status quo, same thing year after year. You want to just keep evolving, keep learning, kind of like those ancestors did. The pictures of our ancestors that I showed you. Didn't that evolve through time? They didn't stagnate at any one point, kind of like we are today. Kind of challenge you to think about that. We may think we're doing new things today, but in essence, it's the same old for the last 30 years or more in some places. So let's think about that. I've focused on regenerative practices. My friend Jim Ristow, he gave me some worm juice. Yep, you heard it here. I am not, as a scientist, recommending this as a practice, but you should know about all the biological products that are being become available today. And so we're just kind of experimenting, making our own. And I've tried some organic leachate. I think the biggest thing, the most solid thing, is the pollinator plots. We've put in a few acres of those, and they're hard to get established, but here's some pictures of some of the flowers that we have in some of those plots. There's the organic leachate. Jim tells me it's basically humic acid and some biology, and that's what it looked like pouring it into the sprayer tank. And it's good stuff. He gave me that tub, and I didn't know what I wanted to do with it, and I had it in my shop, and it didn't smell at all. It's great stuff. And I put it outside, and it rained and it filled up. And one evening I walked by and said, boy, that's some good looking stuff. I got to harvest it. So I did, and I sprayed it. Do I have any results? No, I don't. But this is the coming thing. I really believe that as I'm ending the final years of my career. I say that I'm an inorganic agronomist trained at SDSU by some great professors and great program there. I hate to be too proud, but that's the right word in this case. Proud of that training and who those folks were and are. But we're really transitioning to organic agronomy, not in the sense of without chemical but focusing on the biology more. And we should, because that's how we progress. Remember, I started with the ancestors. And now, can you kind of see that establishment that I'm trying to make? Okay. So why am I confident? Because it's science. Soil health is science. Respective scientists are saying the same things that I'm sharing with you here today. My mentors led the way with this. I think of Dr. Schumacher at SDSU specifically. There are others as well. Of course, Sandeep replaced Dr. Kumar, and now we're looking for a new one. But there, and I'm going to show you some research quickly here. I need to get moving. So history has shown us that depletion of water and soil resources lead to social downfall. That's a known fact. And there are farmer examples doing these practices all over. So really, you can't do that here. So that's my thesis for the day, is that you can. And so here's a map of people that are willing to share their ideas with others. And almost every county has a star or a dot in it. And those counties that don't, I know there are farmers there doing it as well. They're just, don't want to be in the public eye, and that's okay. So these are folks that have agreed to be in the public eye. And so this is an example of doing it everywhere. Okay, just want to put that out there. I want to show you some science about crop rotations. There's a reference. Here's the data. There are the identifiable soil health parameters, and every one of them, the 4-year rotation is better than the 2-year rotation. And the 2-year is the corn and soybean rotation. The 4-year has oats and alfalfa in it. So every one of those parameters is better in the 4-year rotation. I'm not going to dwell on that. We can do that later. Here's some data from my farm. There it is. I'm going to throw it out there for the whole world to see. Farmers don't like to share their data. I'm going to do it. I'm going to build the case that my neighbor with a very good soil there, and I do know this neighbor, and he had a field average 240 bushels an acre. And here are his soils. And the common link here is productivity rating. I know you don't like that, but some people don't like that, but it's the common thing. And so his productivity rating is a 94. And you can see our productivity ratings there in our soils are much lower than that 94. So if I adjust his yield to 100%, that's 255 bushels. And then if I take my productivity ratings times that 255, I get that last column in the table. So those four, 5 fields there, it shows you what the yield should be compared to that 255, right? And so my yields are there in 21. And you can see every example except the one, I've exceeded that by 20 to 30 bushels in some cases. And so I think our soil health practices on our farm have paid off tremendously. I know we're building soil, and I know we're conserving our resources and building carbon as well. Now there's the mistake, the 149. There's the mistake. That was a wrong hybrid choice. And I can verify that by talking to my agronomist that I work with, that I buy the corn from, that hybrid did poorly in the whole region. So I don't feel too bad about that. I feel bad I made that mistake, of course, but I don't feel bad that it's the soil health or the no-till that's causing that. Okay, so there it is. So this is the soil fertility on the farm. There's a zone map of one of the fields. And we're not big farmers. I can't be a big farmer. I work for SDSU. And if there's any administrators on, yeah, I work for you. But this gives me a little validity. And people know that. And I've tried not to share it as much. And I think my friends have convinced me that I need to a little bit. And so there's the soil test. The pH is level there in the green, which I'm happy about. I'm managing my Olson phosphorus test between 10 and 12. Yes, there's variability. I talk about that when I teach, that we have that variability in soil testing. We know that variability occurs. So look at the historic data on your farm and look at where that line is going. Is it flat? Is it going down? Is it going up? What is it doing? So the P is good. The pH is good. The zinc is good, but the K I'm worried about. The potassium there on the right graph, I'm really concerned about. One place I've kind of started to deviate from what I preach is my nitrogen management. And I think we're going to change our nitrogen recs in South Dakota, not based on my experience, but my professional experience with the plots that I've worked with across the state and everything. But on my farm, I've varied my nitrogen rate on my zones based on basically productivity. The higher producing zones get less in. And you can see my nitrogen rates there on that lower right table. But if you look at the nitrates that was in the soil there from those tests, it follows along really well. And maybe that's coincidental on in this field. I don't know, but that's the approach I've been taking. Organic matter is great. Carbon belongs to you. Build it and keep it. This is my professional opinion right now. If they want to pay you for practices, then take that money. If it's economical to the budget, you have to do the budget. Can you afford to do it for what they pay? That is my professional opinion right now. But really, it's about organic matter. This is the organic matter on my farm, our farm, since way back in time. I kind of did a later years approach there, and that's what I come up with there in the orange. The slope of the line is a little more drastic in the more recent years. We know that organic matter and carbon are really closely related. Here's a couple of studies that I've been a part of, not on my farm. Now I'm gone away from my farm now. Well, there's one more slide and then we're totally away. But we know that they're related. This is not a hidden fact. This is 2 independent studies here that I've done can confirm that, and many other scientists as well. We know this. So I've converted organic matters on our farm to carbon, because now I have a equation relationship we can do that with. And so there's the carbon. You can see on the bottom there that I've calculated the value of that carbon increase over the last many years. At 100 tons CO2 equivalent, it comes out to be pretty substantial. $1,700 an acre there across the farm. So that's very important that you understand the value of your carbon. A good friend of mine, Al Miron, the late Al Miron, really a super guy. Learned a lot from Al, partner, soil health advocate, very strong in that. And so his wife gave me his data. And here's the data from Al's farm. His farm is just northwest of Sioux Falls here. A strong increase in organic matter there. Of course, I converted that to carbon, same story. The value per acre of the carbon increase on his farm is in that $2,000 to $5,000 range at $100 a ton. We can argue, we can debate what that number should be. Should it be $20 a ton or should it be $200 a ton? I think that's the problem with the carbon, is that exchange and that money, what that should be. So I had the opportunity to work with an agronomist and kind of in the east central center part of our state. I'm not going to tell you who this is or where this data is from. I respect the integrity of the people I work with. But over 7,000 samples, 15 different farms, gave me all of the organic matter data. I used that carbon equation to convert it to soil organic carbon. And then what do you do with 7,000 data points? And so I divided it into what I call land use classes. And I'm a director of Every Acre Counts program. And so I'm focusing on marginal lands. And so we have our marginal lands there, our salty soils that are developing, our eroded soils are another one, our wetland soils, and then we have our gravelly type sandier soils because of their low water holding capacity have a problem. And then we have just our really good cropland soils. And so I divided them into those groups, those four groups there. And then I had to find a parameter that was consistent across all of those samples. And so what I knew that I could use is soil productivity rating, because these samples are from zones, management zones created from soil productivity. And a very detailed soil map was created to create these zones. So I knew I could put a name to these zones, and then I had a number. And so I got the number, and here's a relationship. It's kind of interesting. Basically, it's a mess to most people, but there's 4 lines there with those 4 classes of soil marginal lands. And we've got our just, good productive soils there. We're increasing carbon as we increase productivity rating. Imagine that. Producing more biomass means more carbon. And that's exactly what this says. But if you look at the left-hand side, there's some soils there that are losing carbon. They're losing carbon. And it's about 60 and up for productivity rating are gaining carbon, and 60 and below are losing. Okay. So even with what we think are good producing soils, those blue triangles, we still have some of those losing carbon. Now, the other marginal lands, the gravels and the wetlands, same picture, but it's all moved down a little bit because we have lower productivity ratings in those soils. So we've done a good job of distinguishing the difference there. But again, the story is good soils building, poor soils losing. The clinker in all of this is those salty soils. They're in the yellow hashes, if you will. The higher producing soils, or the soils with higher productivity ratings aren't gaining in carbon as much as the poor. And I think what happened is this salt effect has taken over in the last 30 years or so. And at one time on those farms, those soils that are salty now were the highest producing soils on those farms. And now this problem has come along, and so we see a reduction in those carbon numbers. So just something to think about when it comes to carbon. I don't have all the answers, don't even claim to want to even go there, but just kind of the way I look at it. Another study, prairie, the cropland, carbon higher in the prairie. Take home message. Sorry. And pH, look at cropland soils have lower pHs. We've acidified our cropland soils. Bulk density, higher in our cropland soils. Another study, lastly, to get to here is Dr. Kumar and his graduate students. There they are out working in the field. They're pounding these cores in the field. I'll show you a picture there, but that's just the sampler that they used. It's a plastic plexiglass core put in a CT scanner. And maybe some of you can relate to those scanners. I've laid in one, but so I put that core in that scanner, and they get a scan, and they looked at 3 different things here, and we've got native grass on the right, and what the green shows are the pore spaces, the open spaces in the soil. Okay, so a lot of porosity in that native grass, well-managed pasture. The bottom left is what we call the soil health principles core. It has all of the soil health principles that are managed well. Now we see less pores than the native grass, but if you contrast that to the conventionally tilled corn and soybean core there, you can see a big difference. There's way less pores in that conventionally tilled field. What do engineers do to a road when they build it? They want a firm roadbed, no pores. They want a solid material, right? So that water can't infiltrate it and break it up, right? They do tillage. Tillage takes out pores. Sometimes it can put it in, there's no doubt. It can put it in and we can have too many, but over time, till, the pores go away. So here's a great example. Here's the numbers, the porosity, it just reflects those visuals I just showed you. I converted the bulk density into something you can relate to, pounds per cubic foot. If you want to shovel, you can notice the difference in that bulk density in the shovel. Where do I go on our farm to get soil for my wife and my mom when they want to plant a bed of flowers or whatever? I go to our tree grove because it shovels a lot easier. Be just like this native grass example. Big difference in the weight because there's more pores. Okay. The internal water movement is superior in the native grass and a little less in the soil health. But look at the conventional tillage. It can't move as much water inside internally because there's less pores. And of course, the carbon, same trend there as well. I made pie graphs of Sandeep's data. And because we know this typical pie graph is that upper left there where it's half voids and half solids. That's the textbook graph. And that's essentially what the conventional till in this example is. Those are the numbers from the conventional till. So I did the same for the soil health system and the native grass system, made those pie graphs. And you could see that the soil health system is not the typical graph from the textbook. There's way more voids. There's more opportunity for water storage in the soil health system. But compare it to the native grass, that's 2/3 voids. That's mind-boggling. So somewhere we've gone from the native grass before the prairie was broke to the conventional till. That's been our effect. So that's why we educate about soil health. This is why we do that. Okay. Anyway, so the science is absolute proof that soil health practices improve soil health. Imagine that. So thanks to Sandeep and Navdeep for their work. So in summary, really, you can't do that here. Think about that. Really, you should do this everywhere, right? It should be just a norm. And that's what we're working towards. And this is soil health practices. I don't think we have any choice, basically. So I think I've taken up too much of my time, or maybe I've come in landed right perfect. I don't know. But thank you for your time today. And look forward to meeting you in person out and about.
All right, thank you so much, Anthony. I'm going to go ahead and throw up that CCA credit for everyone. And I do believe you have a couple questions as well, Anthony.
Okay.
From Tamara, she's asking if you notice any herbicide decrease with your rotation.
Yes, I do. The need. Let's rephrase that a little bit. Do I notice a decreased need? Yes, I do. As an agronomist, am I willing to take chances with less herbicide? I haven't done that fully yet. But I do know this, that the rotation, like I said, forces me to use different modes of action. And so it's helped our farm in that diversification. So while the crop diversification leads to pest control diversification, which is great. I mean, that's so important. Hope that answered the question.
And then I think you do have one more question from Carl. He's asking, what is the depth of that core sample that you were showing earlier?
The depth is 3 inches. Yep, I should have had that on there. I apologize for that. Yep, 3 inches. Great question.
All right, do we have any more questions? Well, if not, once again, we appreciate you speaking with us today, Anthony. And we hope that you all join us tomorrow where we discuss precision cover cropping systems. So, thank you.
Yep. Thank you for your time. Have a good day.